I'm going to talk about R and MongoDB. Good. For myself, I'm Markus. I'm working for comSysto as a big data analyst. So most of you probably know my profile. I'm working on a project with Telefonica, doing a lot of R analysis there, especially with Hadoop and MongoDB. So I got a lot of background in running big data applications with Mongo, Hadoop in combination with R in the last 12 months. Okay, today I want to talk about a little bit big data, Mongo Soup and NoSQL, especially what means schema-less database design for statistics. So what are challenges in there? Then I'm going to talk about the connection between R and MongoDB, and at the end I have several questions, space for open questions, and I also have questions to the community to get some feedback what you are interested in a database connection. Okay, starting with big data. I copied here the explanation from Wikipedia. So if we talk about big data, we talk about the big amount of data sets and the complexity in the data and the complexity of the algorithms. So there are two main factors. On the one hand side, it's the storing of data, how to store them efficiently, how to index them, how to access them. And on the other side, there's the processing. What kind of algorithm you're going to run on your big data, which methods. If there are big amounts of data in the background, the process is running very long, do we have to optimize them? Or can we develop new methods to get much more knowledge out of the big data? So in my view, there are storing and processing, though there are two different aspects you have to care about. Okay, today if we talk about big data, most people think about NoSQL solutions. What means NoSQL? Okay, there's no SQL in the data, on the data modeling. It's a very simple definition, but NoSQL is more or less a mechanism to store and to get your data from a database. And the main factor is that it's as simple as possible, which means you can throw your data in there and as you're interested in. So you don't have to define any formats or anything, just put your data in there and there will be a way to get it out of the database. And so if you think about all these relational SQL world, you have a lot of theories in the background, how you have to model your tables and your data and mechanism. All of them are not available for NoSQL. And so you have a very low-level consistency model, and a lot of people prefer talking about schema-less databases. So in the relational world, you have a schema which defines your columns and the names of the columns, so that's a schema. Schema-less means there's no kind of this definition. And here I listed some of the most famous NoSQL databases. So MongoDB and Cassandra are very famous. On Amazon you have AWS SimpleDB. If you're on Hadoop, you have HBase. If you're more interested in graph-oriented databases, you should check for Neo4j. So there are many on the market. So just go in Google and check for NoSQL databases. I found a list with 112 NoSQL databases. So there's a huge family out there. Yeah, I found another very nice picture. So it's all about hating relations in NoSQL. You don't want to introduce any relations. And to give you a feeling for that, I've found a nice picture. And very common way in NoSQL to represent data is JSON. So here you can see the JSON format for one document, and you have everything in one document. We have in there the ID, the name, the last name, city, and state. So NoSQL mostly means throw everything in one document. In the relational world, you probably would create two tables. here in the one table you have the user information, in the other table you have the address information, and you have any keys which combine both tables. In this case it's a zip ID, so where you can use Frank Weigel has zip ID 2 and you get to this address living over there. So now let's think a little bit more about NoSQL. As I already said, in relational world you define your column, you define your names, you define which data type, if it's a character, a double. So you have to do a lot of work in advance to set up your database table. And then there's one advantage: if you want to insert a data type which doesn't match to the definition, you will get an error. A schema-less database is the other way around. You can throw everything in there and you don't have to do any definitions. There's no work in advance. But you still have some fields. They mostly have a name, so there's some structure in there. So it's somehow an implicit schema. And why an implicit schema? If you think about data, you need some way to access them. For example, if you go back to this one, somehow we are interested in all first names, so we have to know what's the name of the key value pair to get the first name. So this first is some kind of the implicit schema in my NoSQL world. So it's not completely schema-less, so there is a small amount of schema, and based on that, there could be errors too. For example, if you try to import in a NoSQL database only values without keys, so it will be difficult. I have another example here about what is possible in NoSQL but probably will kill you in the relational world. So the first document, Martin Fowler, he has the zip ID, which is a sub-document with city Munich, zip code, and then he has a credit card ID with this number. The next person, Pramod Zadalek, has a zip ID too, but this is coming from different, for example, from different web portals. The first one is storing this in sub-document. The second web portal is creating a long character string with the address in there. This is working in NoSQL world. You can store this in zip ID, even if you had in zip ID another format in advance. And the third document, it gets more critical. The key changed. So now it's not last, it's surname. So it works in JSON and NoSQL, but in the relational world it will kill you. And the other example is the card ID. This user has 2 credit cards, and now you don't have a number here, you have a vector of numbers. And now let's get a little bit to R. Think about having this data structure in R.
Yeah. You say JSON and it works. How would I access it without knowing the keys?
Good question. We get to one of these in the next slides. But for example, my point here is it will kill you for statistics. As you said, if you don't know the name. For example, if you want to get all last names and want to do some statistics on all last names, you will only get Fowler and Zadalek. You will never get this person. So you will lose it in the database. It will keep there all the time. Even if you are interested in running any operation on the card ID, you probably would never know that there's an error in there, and you only take this one, and your algorithm only accepts an integer. You will get an error if it gets the vector out of your database. So there's many steps which especially will kill you if you're doing statistics on your NoSQL database or data structure. One database which is my preferred database, which is the mostly used database, NoSQL database currently is called MongoDB. It's a document-oriented database, and compared to other technologies or other NoSQL databases, there are many advantages using this database. I don't want to talk that much about these advantages and the disadvantages now. I want to give one hint. There's a new service out since about 1 month. It's called MongoDB Soup, which means that you can get Mongo as a service in the cloud. It's completely hosted in the cloud. It's running on German machines, so if you want to use Mongo on a German infrastructure, you need all the business support. You should check for MongoDB Soup. And as you will see in my examples, you can connect to MongoDB Soup by R2, so it works very well. I don't want to talk today about processing big data. If you're interested in that, next week I'm on the Strata in London giving a tutorial about processing big data with R. And in December there will be a very similar event here in Munich, hosted here in comSysto, a tutorial about processing R and big data. Okay, the interesting part, ARM databases. So if we get back to R, most of you are familiar with vectors, lists, and data frames. So these are the most famous data objects in R. And if you think about a data frame, it's more or less only an extension of a list, but it's relational. So it's a matrix, and the columns are defined, the rows are defined, all the types of a column has to be the same, so you cannot put an integer and a vector to the same column, so that's not working. So we are very strongly relational in R. And even if you check all the SQL words in R, there are many places which you can use to connect, and in the SQL world there are new areas where SQL jumps up and gets more interesting again, like all these real-time analysis. On Hadoop it's called Hive, Impala, Drill. So there are a lot of technologies which go back to SQL to get queries with a very, very high performance out of some data storages. And they are all SQL based, and you can connect to them from R2. I have an example here. I used the very famous Iris dataset. I loaded this. I only print the first 3 lines, the rows of the dataset, and I check the class here, so it's really a data frame. And there's a package called SQLDF. It enables you to run SQL queries on your data frames. So you load the package, then you call the command SQLDF and parse a character string to it. Select star from your R object, this is called iris, limit equal 2, will give me the first 2 rows of my data set. And you then can do all the kind of SQL queries you're used to. For example, here I'm doing a count on my data set, and as you can see there are 150 rows into this data set. If you do a dim with R function dim on it, you will get the same result. So if you're more familiar to SQL than to R, you can use this package for all your work on R objects. The interesting part in the background, SQLDF is setting up some kind of flat table, moving your R object in there, and has an SQL engine in the package integrated. So it's really the full power of SQL included here. Okay, and as already said, there are many other packages in R available to connect to this SQL world. For example, MySQL, Postgres, Oracle. All of them have their own package to connect to the SQL world. And the same for SQLite, it gets more and more famous. It was on number 12 in the most downloaded packages. last year, so it's very famous tool. They all have one problem in common. If you send a query to the database, so like the query I had here, this select star from Iris, it will take all the elements which are the result of the query into your memory of R. And if you're really working with big data, this will fill up your memory very fast and probably kill your application because there's too much memory. And not enough memory, and the object is too big. If we check the connection to the NoSQL worlds, or there's for example a package rCassandra available, rHbase, rhive, all of them are available. For Mongo there are two packages. One is rmongodb, which is very powerful for big data. Until yesterday, or until this morning, it was difficult to use because you had to create some so-called BSON objects to query the database. And rmongo is another one. It's very simple to use. It's very similar to the Mongo syntax, but the functionality is limited. It's not all functionality from Mongo implemented in there. It had the same problem. It reads the full results in our memory, and it's really difficult to get it running on a Mac system. Okay, here's some examples from rmongo. You load the package, you have to connect to a database. In this case, it's the MongoDB Soup database with this name, that's the host, that's the port. And then you have to do the authentication with the username and password. Then you get a Mongo object which you can use to, for example, show all collections stored in your MongoDB, and you will get a vector with the names of all collections. So I have 6 collections in this Mongo database. For Mac users, you need this environment setting to omit some kind of Java threading in the background. Okay, so here's some examples. DB get query executes a query on the Mongo database on the ZIPs collection, and this JSON string means that the state key should be equal to AL, and then with limit I only want to get the first 3 rows, and that's the result out of it. So you can also insert documents like written here, and you can disconnect from your database. So you have the core functionality available. rmongodb, it's available since about 2.5 years, but unfortunately the maintainer got lost, so he's not responding to any email, he's not anymore working for his old company, so there was no way to get in contact with him for more than 6 months. So the package got kicked out of CRAN in September, and 2 weeks ago we from MongoDB Soup decided to overtake the maintenance, so I am the new maintainer. We created a GitHub repository, did a lot of bug fixing, and since Friday we are back on CRAN, so with our MongoDB, so you can install it as usual with install.packages now, and so we have the plan to develop a lot of new features in there. So if you're interested in more details, you should check the GitHub page, and I would even invite you to submit issues or feedback if you're using it to put it in the right direction, the new developments. Okay, the MongoDB package is based on the C driver connecting to Mongo, so there's a lot of C code in this package. The same as rmongo, first of all we have to create a connection where we have to define the host, database, the username and the password. We get a Mongo object. If you print it, you get this syntax, which is some kind of pointer that it's C in the background, so not that much information to read out of there, but it's an object with all the information stored to connect to Mongo. And then there are commands like Mongo get database collections, so that you get the collections in your database. and there's even the functionality to disconnect from the Mongo database. Now, if you want to run the query against your Mongo database using rmongodb, this was a little bit difficult so far. In MongoDB, in the background, you have so-called BSON objects, which are binary JSON objects. So it's a binary encoding from JSON objects. And in R, you had to create these kind of BSON objects. So you first of all had to create a BSON object, then you have to append something like state equal AL, and then you have to create from this open buffer, you have to create a BSON object, and it looks like this in this case, which is very difficult to read. You have to know that this 2 means equal character, so the key state should be equal the character AL. So you still can use it today, it's still working this way. And here's the example, Mongo finds 1, which only looks for 1 document in your collection. So you give the connection to the database Mongo, then the name of the collection and the query, and as a result, again, you get a BSON object back, where we had that the state had the character AL, and you have here it's a dataset from the US where you have all the big cities in there. So you have the city name, you have the location of the city, you have the population of the city, the state, and an ID value. And now you have functionality to convert this BSON object to a list object. So Mongo BSON to list creates a list object called out, and I've printed it here. So it's then a usual R object in the list, which you can use as you do it in all your code. What we now changed to the rmongodb package, we introduced a new function called Mongo BSON from JSON, which automatically recreates a BSON object from your JSON, and so it's the same syntax as before, but we don't have to create this BSON object. We just can put the JSON with this command, and it's only 1 line of code, and we will get the same result. So now it's much simpler to use it. So it's new, it's not on CRAN, but it's on GitHub so far.
Just a quick question. You said that the state :2 means that it equals the AL character.
Yeah.
But is it an indicator for the data type in the database, or why is there 2 for 116?
Yes, it's 16 means that's an integer, 2 it's a character. The object ID is a character 2 in MongoDB, so it's more or less it's only for the object, for the type of the value in there. Okay, if you do a Mongo find, now there's an interesting part in Mongo. You will get a cursor. You will not get data. You will get a cursor to your result in the MongoDB database, which means this cursor is very small, will not waste your memory. And if you're now interested to get the results out of your query, you have to iterate over the cursor and get more or less each row of your query result. So I've implemented here a while loop. You have a Mongo cursor next, which iterates over the cursor. Mongo cursor value gets the value of this position of the cursor, and Mongo BSON to list then moves this value to an R value object, so list object which you can use in R. And then here I used rbind to simply put one row after the other and created my result object. At the end I destroy the cursor, and here I printed the head of the result. So now we're getting back to some schema-less stuff. You probably saw that we have city, population, state in there. We can put this very similar into the R relational word. So you see here the name of the city, the number of population, the state. but the location was a vector. So it was long-nut values. And that's now a vector, numeric vector length 2. It will be represented like this in R. So you cannot read it if you just print the object to your monitor, but you can access it. If you then go into there and go to this object in there, there will be the numbers in there, but you cannot print it out simply. So it makes the world a little bit difficult for statisticians. What's new, it's not really big data style, but implementing all these while loops was a lot of work and was a little bit horrible in some cases. So we added some kind of functionality, Mongo find.batch, which will do all of the stuff for you in the background. And you can put the JSON in there, and as a result you get the same as before, but it's only one line of code. Yeah.
Does this only work if the first line contains the numeric, the vector of the two for the location? If the first line you find has only an integer in it for location, it will not work, right?
I'm currently implementing a new bind algorithm where it is working. Yeah, so it's this case and cases where, especially if you have, for example here, if you have then some kind of gender or something included, you will have one column here, you have add this column, add none or anything to the database. So there are a lot of merge conflicts based on the NoSQL world, but we started defining a NoSQL class of data objects where we can handle all these in the background.
Another question. If all this processing is in the background and you have maybe a bad query, which basically gives you all the database result, then you have the same problem as with the other package, right?
Yes.
Because the result set is then in memory and...
Yes, yeah.
Okay.
But you still can do these iterating about the cursor. So you now have both possibilities. The one is for simple statistics and the other one is for advanced big data statistics. Okay, so these are slides from old presentation where it was mentioned that it is a big problem creating BSON objects. So now it was a big problem. So here are some examples how to create BSON objects. So there's functionality available to create a BSON object from a list. I don't want to talk that much about this. There are a lot of help pages in the rmongodb package included. And here I added the code for doing aggregation framework on MongoDB. It gets really horrible in BSON objects, and with JSON and the new functionality, it's only one line of code. Here I have another example. This year there was the Cloudera Data Science Challenge, and I was using the dataset there, and if you want to query for users and type in this dataset, so it was a really big amount of code. Today it looks like this and it's the same result. So especially this MongoBSON from JSON, here user equal yes and type equal yes will reduce the amount of code dramatically. And yeah, I just put one example in here from this. It creates a box plot, and so it's a data set with about 10,000 users and 530,000 operations of movies. So it's an online movie database, and if people start and film, it will be an event. If you stop, it will be an event, and if they download, it's an event. And here you can see that on average somewhere around 7 events per user, and there was one user with a lot of events, so it was some of my first analysis I did on this data set. Okay, now I get to your question, how to know what keys are in my collection. And that's the part I'm currently working on, the rmongodb package. So I already implemented this morning a function called MongoGetKeys, which will give you all the keys of a collection. There's also a function available called MongoGetValues.distinct, which will give you the values for one key, and so the unique values for one key. So if you have like the ZIP data set, you will get all countries of the US. And in R, most of you are familiar to all the apply families, so it will give Mongo apply will be available. So 1 normally means per row and 2 by column. Now 1 means by document, 2 means by key. So it's a little bit another syntax in the background, but it's the same functionality. So you're probably familiar to a summary call. You now have mongo.summary, which will give you summary statistics about your collection. Mongo aggregate will do aggregation. Mongo table will give you this table of data count values of objects. And yeah, I'm more or less extending this list every day about new functionality to make it more user-friendly and to put more high-level functionality into the MongoDB package. Yes?
With your new function, I now know where it's the last entry and also the surname key in the database.
Yes.
But I would not know that they are equivalent.
No. 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 You cannot know them. There's no information. Then you have to talk to the people writing the data into your database. But then you probably will know, okay, there's last name and your name, so probably you have to combine both to get a realistic statistics. And for example, with MongoGetKeys, you get the name of the key and the number behind. So that means this key is 500,000 times into the database. And if there are 520 collections, you know that 20 collections don't have this key. And you probably have 20 times your name, so you can combine it afterwards. Find any rules how to make your data set complete. Yeah, another activity I was working about 3 months ago, and I was motivated by the Mongo company to go on with that, is implementing a web-based user interface for MongoDB, which is based on R and especially on Shiny. So Shiny is this very new fancy tool by RStudio to visualize R results in a web-based way, and you are able to interact with your data by buttons and select areas. And so the idea is here to combine Shiny and rmongo, and especially now with the JSON query, to have a MongoDB user interface which is based on R and gives you the possibility to add charts and different stuff into the user interface. So it's also on GitHub, it's public available, so if you're interested you can check for that too, and I hope it's running with the latest rmongodb release. I didn't test it today. Okay, summary. I hope I brought the point that NoSQL can make the life of statisticians really hard, and you have to be aware of different structures in your data. R is a very powerful tool. You can access more or less all databases. With MongoDB and rmongodb, you're really ready for big data. And I would like to invite you to go home and start playing around with rmongodb and providing feedback.